Hello, everyone. Thanks for joining. As an introduction, I would just like to mention that I work at Neo4j as a team lead and consulting engineer in the professional services team. So as part of my job, I get to work directly with Neo4j customers in their project phase, where I help with things like data modeling, query optimization, or application building. And this is what led me to work with Neomodel and also improve Neomodel. As we'll see as a maintainer. So let me share my screen. Okay, so I do have a few slides, but I promise it will be very fast and you won't die by PowerPoint. So before we go on the agenda, something I would like to mention about Neomodel is that it is a community project. It was created by the community. And most of the work that has been done on the project has been led by the community, or sometimes also by customers like Novo Nordisk, which I'm involved with. And they have a project where we actually build some features that we then integrated back into Neomodel. So it's a community project, but it's also part of Neo4j Labs. And what this means is that it has some quality requirements, and it also requires that at least one Neo4j employee must ensure that the project stays alive and keeps getting maintained. So in this case, for the present, that Neo4j employee is myself. So Neomodel is an OGM. We'll see what an OGM is. We'll see quickly the typical architecture for an API using an OGM. And then we'll look at some code. So OGM, that's the graph equivalent of an ORM. So ORM stands for Object Relational Mapper, and OGM is Object Graph Mapper. So it really uses the same principles. The main difference is that OGMs today are less mature than ORMs in general, because graph databases are just way more recent than relational databases. And what it does, in a sense, it allows you to define your domain model as code, and in the case of Neomodel, in Python code. And it simplifies database interaction by proposing some Pythonic principles, and it allows you to walk away from using only Cypher queries. You can even have applications where you have no Cypher query. I love Cypher, but as we'll see, it can have downside. So this is a list of advantages. I'm not going to go over all of them. I have a blog post about that, which should be released pretty soon. But the main points here are abstraction. It provides you with easy interaction with the database. And one point in favor of that is the modeling. So you describe your objects using Python instead of whatever you would use, a diagram or whatever. It also makes the code more maintainable, because using Python code is just more maintainable and debuggable than using Cypher queries, which in essence are just strings inside of your code. And it also allows rapid application development, because as we'll see, it provides you with a lot of shortcuts to interact with the database once you have defined your objects in the code. So here you'll see a very advanced architecture on how to build an API using an OGM. So in the bottom, you have your graph database. So in this case, Neo4j. And on top of that, you will have your API application. So I'll go bottom up here. So you have a set of database actions, so create or read or update actions. And these are, in the end, it will be Cypher queries that get pushed to the database, because that's what the database understands. But it doesn't have to be you writing the Cypher, as we'll see. So it all relies on your object representations that represent the objects that you actually have in the database using Python code. Then on top of that, you have your business logic because as we'll see, what the outside world here expects as an output from your API might be different from what you actually have in the database. So you have to do some kind of transformation and some business logic here. So as we'll see, you can also have an object representation matching with what the outside world expects, and this all lives in the API. These 4 layers. Okay, but before we go too far into the theory, this is where Neomodel is present. So in your object representation and all of the mapping for the actions that you will execute on the database. Okay, so we are all set for a code dive in, as I promised. So you will find here a public repository in GitHub, Neo4j Python API sample that I put together. This contains Neomodel, of course, but also Fast API, which is a framework for building API in Python that you're probably familiar with. And before I jump into the code, just a heads up here, I set in the repo requirements of Neo4j at least 5.11. That's just because I provided a data dump that was made using Neo4j 5.11. But Neomodel itself, it works with every currently supported versions of Neo4j, so 4.4 and all the 5.x versions. It's really not limited only to 5.11 and above. So you will find a guide on how to install and run the API. And here in the bottom, don't spend too much time remembering that, but just a heads up, this is a script that comes with Neomodel that allows you to create indexes and constraints in the Neo4j database automatically by looking at your object representation in the code. Just remember this exists because I will refer to this in the code walkthrough. So for the code here, I have this source folder, and you will see I have 4 files that represents a bit the architecture I had earlier, especially with the API models, database models, and the main, that's the business logic. But before we go in that, just the first thing you always have to do when you want to use Neomodel is set some configuration. That's the simplest level and the absolute minimum that you need to provide a database URL. You provide a protocol, of course, a username, password, hostname, port, and potentially the name of a specific database in your Neo4j server. And once you have this, then in your main file in Python, if you do an action using Neomodel, then it will connect to the database by creating a driver automatically, etc. So of course you have way more configuration options, but you can find that in the documentation. And in the next major release, which will be 5.2, we will actually add a way to pass your own Neo4j driver if you want to be completely in control of the Neo4j driver, which allows you to do things like SSO, for instance. Okay, so as I said, we can have 2 different model representations. First one is the API model, so that's what the outside world will expect. So in this case, it's a little Spotify model. So you have albums, songs, artists, and playlists. And I also provide a class which allows you to create playlists directly. So that's an input model. So that's the API model. Just notice here that a song can have optional albums. This will be important because if you go and look at the database representation of your objects, this is not optional, as we'll see. So here, that's the real part of the core of Neomodel. So I will define a model. So I have a bunch of nodes. So album will be a node. So every time you create an album, it will inherit the label. It will create a node and which will inherit the label album. It will have one property, UID, which is unique ID property, And if you see here, I also have some string properties, float properties, etc. So here the typing is all done by Neomodel. And one important thing here you can notice is unique ID property will create a uniqueness constraint automatically when we run the script that I was mentioning. Also index equal true. This will create an index for you on the title property of the nodes with the label song. So this is really handy because you just describe your model as Python code, and this will actually define what you have in your database. And as I was saying here, albums, that's not mandatory. A song must be features in at least one album. So you can define a cardinality here, one or more, which means you cannot create a song if you don't also link it with an album at the same time. So that's for the model description. And if I go into the main part of my application, you will see here this is defined through fast API. And when I was saying the database interaction can be super easy, is that here I imported song from the database models. And if I do song.nodes.all, then this will just go and get all the song nodes I have in my database. So if I go here and I call my awesome API, you'll see that the number of songs in my database I have is this number. You can do more complex stuff than that. For example, if you want to list the artists, here I implemented some kind of pagination and ordering. So I do artist.nodes.order by the name property, and then you can do pagination by using the very Pythonic way of slicing. So here I'm actually saying go from 0, for instance, in the default case, from the first entry, and take only 10 entries, which is the size of my page. So here I'm only writing Python, but this will actually get translated to Cypher with all the skip and limit and order by and whatever, without you having to write Cypher, which is super handy. And here, when I map my artists into the API model that I will send out of the API, I say, okay, this is the properties for my artists, but I also want to return the songs. So here, what do? I also traverse the relationships. So for every artist I have fetched from the database, I go fetch the songs by doing a.songs.all, songs being the name of the relationship in my Python class. And then I just parse all the songs I'm getting into the song API, which is the API that the model that the API expects as output. So that's it for getting nodes. And finally here, some CRUD operations, or well, some CUD operations. That's also super easy because I just create an instance of the playlist class, which is part of the database models. I just pass whatever property I want, and then I do save. And then here, let's say I passed a list of UID of songs. I just get all of these songs by the UID. So that's doing match something where UID equal whatever. And then I just do playlist.songs.connect with my song. And that will actually create a relationship. So here, I hope I really showed that it simplifies the database operations that you do 90% of the time. Of course, you probably have more complex use cases, but Neomodel can handle more than that. I will invite you to go read the documentation. And if it doesn't serve all your purposes, you can, of course, run Cypher queries pretty easily by doing db.cypher query. So that's it for my overview of Neomodel. So I just wanted to thank you all for attending this. And I'm a bit lost in the time. Nope, that's the session end. So thank you. And if you have questions, please go to the GitHub repository, and we are monitoring the issues log, and Neomodel is actively maintained again. So yes, thanks again, and please also fill the poll at the end.